bad. Yay!
No.
Technology is working today. Okay. So, we are finding the zeros of polynomial functions today, still using synthetic division. So, that'll be great. Okay. So, basically, we have what is called the rational zeros test. So before, honestly, this last section, they gave you like a specific k value to finish factoring. Okay? They're not going to give you that k value. We actually have to find a zero that actually works by basically like guessing and checking. But the rational zeros test shortens our list. We're not just checking like any random number. Okay? So, I'm going to say it's a test to find rational zeros of a polynomial.
For the record, I'm still not used to Fridays and not getting out at 2:30, and I still don't like it.
Yep, I don't either.
Just for the record.
Okay. I know. Yeah, what's a rational number? Since we're like using that word. Fraction. So a number that can be written as fraction. Yeah. Okay. So it only gives us a select few zeros. So it's not going to give you like anything with the square root symbol. It's not going to give you imaginary zeros. It's only rational zeros. Okay. So let's just say our polynomial has a constant of, oh gosh, p, and a leading coefficient of q. Now we can basically make a list. So I can divide the constant by the leading coefficient, and basically we're finding all the factors of p divided by the factors of q. So we're going to create this lovely list, and then we're going to start guessing and checking, basically. So yeah, we'll do an example that explains this whole p over q situation, and yeah, and we'll do synthetic division with it. Okay. So find all rational zeros of this fourth degree and factor f of x into linear factors. Okay. So we should first identify what p and q are before we start making the list. Yeah. P is a constant, just the number. Q is my leading coefficient, the number of my largest degree. So 6. Okay, so then I want to divide p and q. But now I want to find the factors of 2 and the factors of 6. So what are all the numbers that multiply to 2? Yep, 1 and 2. I'm going to put plus or minus around it because that could be positive or negative. And all the factors of 6 are 1, 2, 3, 6. Yeah. Okay, so these all divide into 6. So this is all great and dandy. Sometimes they'll ask you to list all the possible rational zeros. So we actually need to divide all of these out. So I'm going to take my numerator of 1, divided by every single denominator. So then I have plus or minus 1, because 1 divided by 1 is 1. 1 over 2 is a half. 1 over 3 is a third. 1 over 6 is a sixth. So that's taking the numerator of 1 divided by every denominator. I have to do the same thing with 2. Dividing 2 to everything in the denominator, I get out 2. I get out 1 again, but I'm not going to write it a second time. I have 2/3 and a third, because 2/6 is a third, but I'm not going to write it again. So there's my list. So these are possible rational zeros. Okay, so hopefully we figure out that one of these actually work into my polynomial. Not all of them will work. I could have a total of 4 because my degree is 4. So I should have 4 zeros technically. So basically we're just going to be plugging in numbers to see which one gets out a 0. So I'd probably start with 1 and -1 because hopefully one of those work first. So if we plug in 1 in for every single x value, what do we get out? Yeah. So we find one that works. So I can start making a list. Here's all my zeros. 1 works. I could go and like check all the other ones to see, but I don't like guessing and checking. So this is the point. If we find one, we can do synthetic division on it to basically create my 4th degree polynomial to a cubic and make it a compacted cubic. So then all my coefficients are 6, 7, -12, -3, and 2. So yeah, sorry, I just did that real quick. So this is another verification. We got a remainder of 0. So I'm just going to write verify 1 is a 0. So right now I have a cubic. So I'm just going to write that off to the side. I have 6x to the 3rd power plus 13x squared plus x minus 2. So I would like to try and factor this cubic. Cubics you can always cut in half. But when I take out x squared, I have 6x plus 13 left over. And then if I take out a 1, I have x minus 2 left over. So technically this one doesn't factor by grouping. So that's sad. It'd be nice if it could, but we could just kind of be done here, but not factorable. So I need to go up to my possible rational zeros list and test another one. So I found the one that worked, I need to find another one that works. Because then once it's a quadratic, I can always solve a quadratic, for sure. So maybe let's test like -1 into this guy again. -1 doesn't work. Let's let you know. We could try 2. That's getting above my pay grade here. With that 4th power. Yeah, we can now. I like to try the whole numbers first because I think it's easier. Maybe 2 and -2. Technically, it doesn't matter. You could do it into the cubic. That's 6x to the 3rd. That's 15 squared. Okay, that's easier. You could plug it back into the 4th power. Okay. -1 doesn't work, 2 doesn't work, we should try maybe like -2. Possibly. No, 0 is -2 as well. Okay. So 6, 13, 1, and -2 are my cubic, so I'm just going to do synthetic division. Like continuing my synthetic division instead of rewriting the numbers again. So 6 drops down, multiply, multiply. Okay, same thing, I get a remainder, 0 verifies. -2 is a 0 now, which is nice.
Teachers, kindly put your recycling boxes out.
Ooh. Okay, so what polynomial do I have left over right now? Okay, so here's a quadratic. I should try and factor it unless you want to start testing the fractions. You can absolutely go for that. I think factoring is easier. So we do AC method.
Do you have prompts? Call the office. Yeah.
So what are my numbers? Okay. No, wait, can you rewrite it? So 6x squared plus 3x minus 2x minus 1. Factoring out 3x. Factor out -1. Okay. So this is what I get out factored from my quadratic. I could then set each of them equal to 0 and solve. Okay. So if I listed all my zeros, I had 1, -2, 1/3, and -1/2. Okay. And I could have gotten 1/3 and -1/2 by testing those rational zeros. They fell into the possible list. They also asked us to write it as linear factors. So basically I'm taking my factored form of my quadratic. That's part of it. I can rewrite f of x, the 4th degree polynomial, in factored form. So I have 3x minus 1. I have 2x plus 1. And I also have to write in the 1 and -2 as zeros. So the 1 I write as x minus 1. And the -2 I write as x plus 2. So there's my 4th degree polynomial. And I could check by distributing everything out. But that's no fun. So we're not going to. Okay. Next thing. Yeah. So fundamental theorem of algebra. I kind of talked about it a little bit. So basically, given a polynomial, of degree n, there is at least one in the complex number system. Okay, so I guess I always say with the degree, so our 4th degree polynomial from our last example, I always say we should get 4 zeros. Okay. That typically is always the case. It's just sometimes those zeros could be like repeated, which is what we'll get to the multiplicity of a zero. But for the most part, if you have a fifth degree polynomial, you should have 5 zeros. First degree polynomial, you should have 1 0. But does anybody know what this complex number system, what does that mean? More complex than just a number line. Okay, so these are real and imaginary zeros. So I don't think we're doing imaginary zeros today. We will get to those on Monday. But imaginary zeros come from the quadratic formula. When I can't square root a negative sign, then we get imaginary solutions. We will get to the quadratic formula soon. Okay. So multiplicity of a zero. So I'm going to say a zero, I'm going to put a quotation, occurs, or I can say can occur, more than once. Based on the degree of the linear factor. Okay, for example, I could have a zero of like 3. This zero could be written in factored form as like x minus 3. So if it's just x minus 3, then it's to the first power, so it has a multiplicity of 1. I could raise this linear factor, this quantity, to any power. So I could raise it to the 5th power. So the 0 of 3 has a multiplicity of 5. Because it's like a linear factor is repeated 5 times. Okay, so if they ask for the multiplicity, just look for the degree of the linear factor. Okay? So, I need to rewrite this because this looks like a hot mess. Yeah. So we have this lovely function. Part of it's factored, not all of it. We're going to find all the zeros and determine their multiplicity. So I guess my goal right now would be to factor this x squared minus 3x minus 4 piece. No, wait, I don't have factors. Yep. Okay. So x squared minus 3x minus 4 factors to be this. So the trinomial was raised to the 3rd power, so this whole factored form needs to be raised to the 3rd power. And I still have x minus 1 to the 2nd. Okay, so technically I could distribute this 3 to both linear factors. So if you want to, you don't have to. You can write it like this. 3rd power is going to both linear factors. Okay. So I would like to list all the zeros and their multiplicities. So what is 1, 0? 1. And I'm going to write multiplicity of 2 because it's raised to the 2nd power. I have another 0. 4, multiplicity of, and my last one, and multiplicity of. Okay. So does anybody know what the degree of this polynomial is? Really? Yeah. So if I want to determine the degree, basically I have to add all the multiplicities for the degree of all the linear factors. So it's 2, 3, and 3. This is the degree of 8. So I should have 8 zeros, technically. But they're repeated 2, 3, and 3 times. So, yeah. Okay. Last one. So we would like to write polynomial equations based on the information that's given to us. And they could give you all sorts of random things. But for the most part, if I wanted to write a polynomial function f of x, I could write it in like factored form. So I could have like x minus a times x minus b times x minus c times x minus d, depending on how many zeros that they actually give us. But sometimes I will have a lovely number here, or constant, or whatever you want to call it. And that's part of what we have to figure out. So they will give you zeros, so you should write them in factored form. I'll have to figure out the constant that's in front of everything. Okay, so I know negative 2 is 0. So how can I write that as a linear factor? X plus 2. And then it says it's a multiplicity of 3. So then this has to be raised to the third power to represent the multiplicity. Okay? So if they ask for just a possible polynomial function, I'd be done. But I want the specific one to satisfy this lovely little point. So I need to find, I'm just going to write k here. So I need to find this number right here. So basically I'm going to plug in -1 and 4. -1 is acting as the x value, 4 is the f of x value. So 4 equals k, -1 plus 2 to the third. And I'm going to solve it. So basically k equals 4. So then my polynomial is f of x equals 4x plus 2 to the third power. There's my third degree polynomial. Nice. Good. Okay. Next thing I was going to ask you, the 4 of you that are actually here. So technically our 3-week thing for our test would be Friday of next week. But I didn't know if you wanted to do on Tuesday. So that way we just take a test and be done for Thanksgiving break, or you still want to do it on Friday. And then Monday, Tuesday would be like homework.
So next week is the week that we're not.
Next week is the last full week of school. And then the week after that would be just Monday, Tuesday of school, and Thanksgiving break. Okay.
Then we aren't doing those, and then we lose what we want.
Yeah, I have no preference, so if that's what you guys all want, then that's what I'll do. Okay. That's on Tuesday of Thanksgiving week.
That's what I'm always thinking about, like Christmas break.
Right.
We learn how to spend it, like after we come back.
Yep. All right. So we all write this down.